So today we're going to start talking about significant figures. How many of you have covered significant figures in other classes before? Math class maybe? Nope? Okay. So when we report measured values, we want to make sure that we're all following the same rules for what digits we report and what digits we don't report. And so when we talk about a measured value, all of the digits that we include and communicate are what we call significant figures. So significant figures are a way to communicate to anyone looking at a measured value the accuracy to which you measured that value. And to make sure that everyone everywhere is communicating digits in the same way, we need rules for significant figures. So the first thing we're going to do with significant figures is go through and talk about what is a significant figure and what isn't. Okay? So these come together to make what we call the significant figure rules. You will hear these significant figure rules discussed in different ways, but they all lead to the same conclusion. Okay? So the first rule is any non-zero digit is always significant. So if it's not zero, it is a significant digit. Okay? So if we look at this first number, 12,457, how many significant digits does that number have? If we count them. How many? Five. So this has 5. And then you'll see significant figures abbreviated as sig figs or sig fig. Okay, what about the second number? All non-zero digits, so all of the digits are significant. So I forgot to count. 5, 6, 7, 8. Is that right?
Yes.
Okay. And then the number 2 has 1. So if it's a non-zero digit, it is significant. Easy enough? Okay, the second rule, any zeros. So if all non-zero digits are significant, then we need to deal with when are zeros significant. So the first rule is any zero between two significant digits is significant. So 101, how many significant digits does it have? 3. That 0 is between two non-zero digits, so it's significant. Okay? Then the next one, 1, 2, 3, 4, 5, 6. Okay, so zeros between non-zero digits are significant. So now we need to deal with zeros that aren't between significant digits. Okay? And so there's 2 scenarios for that. We can deal with zeros at the end of a number and zeros at the beginning of a number. So we need 2 more rules. So this third rule is ending zeros, so zeros at the end of the number, are only significant if a decimal point is shown. Okay? So if a decimal point is shown in a number, then are ending zeros significant or not significant? Significant. So if we look at the first number, is there a decimal point shown? So are these ending zeros significant? Yes. So this number has 5 significant figures. Do we agree? What about the second number? Is there a decimal point shown? No. So how many significant digits does that number have? 1. So this leads us to an important point to talk about. If this number 20,000 without a decimal point has only one significant digit, can I just write it as 2? Why not? You're right, you can't just write it as 2. What's the problem with 2 compared to 20,000? They're not the same magnitude, right? They're not the same size number. So if we just said 2, it wouldn't communicate the size of the number. When we say that the number 20,000 without a decimal point only has one significant digit, what we are saying is that the 10,000s place is the only place we can measure accurately. So we can't measure the thousands, the hundreds, the tens, or the ones place. So we use zeros, and those zeros are called placeholders. So ending zeros that aren't significant are called placeholders. And we said those are necessary. Why? What do they tell us? The size of the number? Okay. This is what I like about OneNote. I can add in examples. You'll be able to see them in your OneNote. It allows me flexibility. Okay, so what about the number 35.000? Are those ending zeros significant? Yes, why? There's a decimal point shown. So how many sig figs does this number have? 5. Well, what about the number 35.0? How many significant figures does that have? 3. So if we were just looking at those numbers, we would say both of those numbers say 35, right? And if we were counting things like people, then yes, 35 is 35. Doesn't matter how many zeros we put at the end of it. But the difference between 35.000 and 35.0 is that the first one, what we are communicating to people who see that measured value, is that we could accurately measure the number 35.000 to the thousands place. Whereas 35.0, we are communicating we could only measure to the 10th place. Do you see the difference? And then what about the number 35? 2 significant figures. So now, yes?
If you had a number like 20,000 and you wanted to specify that like only the 1,000 and 10,000 places could be found accurately, how would you show that?
So you said 20,000 to the tens? 10, which place? I know, pick one. Which place?
Like just the 20 at the beginning?
Okay, to the thousandth place?
Yeah.
Thousands. Okay, very good question. So if I had the number 20,000 and I wanted to communicate that I could measure the 10,000s place and the thousands place, how would I communicate that? Can I write 20 point nothing? Why not? It's a different size number. So the way that we can clearly communicate significant figures is using scientific notation. Does anyone know what that means? What is scientific notation? You use a multiple of 10, right, to tell how many times you'd multiply a number by 10 to get back to your original number. So if I wanted to write 20,000 and communicate that the thousand place is significant, I would write it like this. 2.0 times 10 to the what power? How many times do I have to multiply this number by 10? 4. So to the fourth power. So when you get into situations where significant figures are ambiguous, what can you do with your number? Write it in scientific notation. Very good. And then our last rule deals with zeros at the beginning. So leading zeros are not significant. So if you have not reached a non-zero digit, those zeros aren't significant. So can I just delete them? No, why not? Different magnitude. Those are also placeholders. So in the first example, 0.00056, how many significant figures are there? 2. Okay, then the last one, we have to use 2 different rules, right? Are the leading zeros significant? No. Are the ending zeros significant? Why? There's a decimal point. So how many significant figures does this number have? 6. So another way to state this fourth rule is that you don't start counting significant figures until you get to the first non-zero digit. It means the same thing. Same rule, just stated in a different way. Another thing about significant figures, if you're looking at a given number, you're not going to start counting significant figures, stop, and then start again. All of the digits, once you start counting, will be significant until you reach a digit that's not significant, and then you stop counting significant figures for that digit. And if you follow the rules, they will they're built so that that won't happen. Not so bad? Okay, so let's look at some examples. So throughout the notes, you'll see modeled examples. Sometimes the work will already be on the OneNote for you. Sometimes it won't be, and we'll go over it in person and work it out on the screen together, and I'll model how to work it. You guys will have those as like worked examples. So if we look at the first example, are these leading zeros significant? No. Are the ending zeros significant? Yes. So it's going to have 3 significant figures. And we could write it in scientific notation. So in this case, if we're making a smaller number look bigger, are we going to be multiplying by 10 or dividing by 10? Dividing by 10. So we'd write 6.82, and then we'd need to divide that number by 10 3 times. And we can write dividing by 10 as multiplying by 10 to the negative power. So it would be 6.82 times 10 to the negative third power. Okay? The next one has 4 significant figures. What about 300 without a decimal point shown? 1. And so if we were going to write that in scientific notation, all of the digits that we show are significant. So we'd write it as 3 with 1 significant figure times 10 to the second power. Does that make sense? So when you're writing a number in scientific notation, you need to show all the significant digits before your times 10 to the power. 300 with a decimal point shown, what does that decimal point communicate to us? That those ending zeros are significant? So it's going to have 3 significant figures. So if you wanted to write that number in scientific notation, you would need to include the 2 zeros because they are what? Significant. So it would be 3.00 times 10 to the second. And then 300.0, all of the ending zeros are significant. Why? Decimal point shown. So there's 4 significant digits. And if you wanted to write it in scientific notation, you'd need 4 digits before the times 10 to communicate the significant figures. How are we feeling about significant figures? Good. Okay, so I want you guys to now work on the student examples.